Our next panel, entitled The Factory of the Future, Robotics in Manufacturing, will be moderated by Liza Tobin, Senior Director for Economy at the Special Competitive Studies Project. Please welcome our speakers. Dr. Robert Atkinson, founder and president of the Information Technology and Innovation Foundation. Ira Moskowitz, CEO of the Advanced Robotics for Manufacturing Institute. Dr. Chetan Gupta, head of AI research at Hitachi, and Ed Mehr, co-founder and CEO of Machina Labs.
Good afternoon. I'm thrilled to have with us today 4 experts who are going to shed insights onto some very important questions. How are AI and robotics revolutionizing the manufacturing sector, something that matters to all of us? How competitive is the US globally? How are we doing vis-a-vis China and other countries? And what do policymakers need to know about how advances in AI and robotics can transform how we make things in the industrial sector? So I am going to dive right in and call on Rob first because he is a SCSP advisor, and I want to start with the big picture. So Rob, can you just help us understand how does the United States stack up in terms of deploying and developing robotics for the manufacturing and industrial sectors, especially vis-a-vis China and any other major competitors that you want to mention?
Sure. Well, thanks, Liza. The short answer to both is not very well. When it comes to robotic adoption by manufacturers, China is now ahead of us. They have more robots per manufacturing worker than the US does, and that's dramatically changed in the last 7 years. When it comes to controlling for wage levels, so it doesn't make a lot of sense to adopt a robot if you're paying your worker 10 cents an hour. If you're paying them $40 an hour, it makes a lot of sense. So if you do a model where you control for the lower Chinese wages, they have 12 times more industrial robots than the US. We're seeing that in the fact that right now, US manufacturing productivity has been declining. This is, again, unprecedented. If we collected statistics back to 1789, we would never have seen this in our history. It's only in the last 10 years when we've seen either stagnant or declining manufacturing productivity growth. So by and large, our companies are not adopting industrial robots at anywhere near the pace of the leaders, Korea, Japan, Singapore, Germany. And we're ahead of Canada, we're ahead of the UK, but yeah, that's not a high bar. When it comes to development, the US used to lead in machine tools, sort of robotics. In fact, we were the inventor of robotics. Today, we have no major robot companies by and large. The dominant companies are Japanese, Swiss, and German. We just don't have a lot of robot companies anymore. The Chinese are going great guns on robots. So we did a study, it's on our website, assessing Chinese robotic innovation. And it's pretty amazing. They're still not quite as good as the Japanese, the Germans, and the Swiss, but they are making incredible progress. And part of the reason is over half of the industrial robots installed last year were installed in China. So they have this huge captive market because they're incented to buy Chinese robots. That's going to give them advantages on innovation and learning. And secondly, the amount of money that the Chinese are putting into robotics is mind-boggling, staggering. Certain provinces are putting in $1 billion, $2 billion into robotics development. They have a robotic, my last point is they have a robotics center. We have, in fact, we just did an event this morning on the Hill on the US Manufacturing USA Center program, which is a great program, but it's frankly not very well funded. The Chinese have a center, which is the name of it, the Dongguan Robot City. It's a government-supported robotic research institute, and virtually every Chinese robot company is contiguous to that with R&D and early-stage production facilities. And it's getting, way, way more money than our great center we have in Pittsburgh, which you'll talk about. It's a great center, but and funding levels compared to what they're doing in China is quite limited. So I think there's huge opportunities. The main opportunity we have is we have a lot of innovative robotic startups, and we're way better than a lot of other countries in integrating software, including AI, into robotics. But that hasn't translated yet into high levels of adoption or companies that have been able to scale.
Thanks for that global perspective. I want to zoom in now and hear, especially from our private sector panelists. Chetan, I'm going to turn to you first, mostly because you just told me that one of the earliest robots back in 1964 was the Liza robot, so you get extra credit for that one. So just for the industry perspective, Hitachi is doing some really interesting work in this space. Can you just tell us a bit about how you are integrating AI and machine learning into industrial and infrastructure solutions, and maybe give a concrete example for our audience?
I will sort of first build on what Robert said earlier about the lack of focus in some sense about AI in the physical world in North America, especially in the US, if you compare it with, say, other countries. A lot of our AI conversation is dominated by the social media companies. I think that's one thing to think about from a policy and a strategy perspective in the longer term. From a Hitachi standpoint, I don't know how many people know Hitachi, but Hitachi is a very diverse company. So for example, the electricity grid, a lot of the electricity in the world runs on Hitachi networks. Hitachi is building the next set of rail cars for Washington Metro. We also make inspection equipment for semiconductors, and also builds digital solutions for other companies. So, and we are systematically thinking about AI in all of these aspects of what we do. So we call it industrial AI. I think that's a word used Liza as well. And so there is a lot of innovation in industrial AI that Hitachi is bringing to the world. For example, we're thinking of train as a sensor. So for example, when the train is moving through tracks, can you use it to know the status of the tracks, status of surroundings? We are bringing AI into the electricity grid by by balancing supply and demand, bringing into the shop floor in manufacturing, by introducing AI and robotics into our factories. For example, the factory in, I think it's very close in Washington, D.C. for the rail car. It's called a MAD factory, the world's most advanced factory. And it has one of those spot robots for inspection. The supply chain is being digitized. A lot of visual inspection using cameras for defects in production. So that kind of sort of integration of robotics and AI. And we also build these solutions, and we've been building this for quite some time for our partners and customers. For example, Penske, which is I think the largest fleet in North America, uses a lot of AI technologies developed by Hitachi. So when the truck comes in for repair, the technician is being helped in doing the right repair because it's a hard job. And a lot of young people don't want to work on the shop floor anymore. And the old skills, so we're losing sort of the domain knowledge that you need to do these things. So that is AI powered today based on our technology. When the truck is in the field, we can predict when it's going to fail. So you can bring it into the shop before it fails on the side of the road. And we're building infrastructure for sort of inspection of these vehicles. So at if you think around the physical world, the way Hitachi thinks about AI is how do we bring this AI from sort of as someone said earlier, cognitive world to the cognitive plus physical world. And that applies to both manufacturing, to operations, to maintenance, the whole stack.
Thank you. I want to stick with the private sector for a moment. Ed, I remember when my team and I came across Machina Labs when we were doing our research on advanced manufacturing, and we got really excited. Could you explain your thesis to us and tell us a bit about your robotic blacksmith?
Yeah. So our thesis is that kind of maybe if you look at what problems are the major problems that we have in manufacturing, especially as it relates to reshoring, we kind of narrowed it down. It comes down to flexibility of factories, right? When I was at SpaceX, SpaceX, as anybody would know, is one of the most advanced companies in this area, in the area of manufacturing. In the span of 20-something years, we only developed two rocket vehicle families, the Falcon family and Starship. Why? Because the moment you build a shop floor to build a rocket, a lot of tooling, a lot of specific machinery goes into that shop floor that cannot easily change if you want to change your design, if you want to change your material, right? And if you look at this problem more globally, I think it's also at the root of why manufacturing is centralized in Southeast Asia. If you have factories that cannot change, they need to build products for the rest of the world for them to be economical, and they will eventually centralize, big factories centralize in the cheapest area of labor, right? So our thesis at Machina was how can you build factories that are flexible and agile, can easily change? And our answer to that was something we kind of took from the history. Build a robotic craftsman, right? A craftsman is a very flexible manufacturer. They can use different tools, apply it differently to material, do different types of processes, work with different types of material very flexibly because they have a creative mind and a lot of degrees of freedom to work with the material. So at Mach, what we're working on is building a robotic craftsman, a system that like a craftsman can do different types of manufacturing operations. We started with sheet forming, which is the largest metal processing sector today. If you're sitting in your car, you're in a freeway, you're in a sea of sheet metal. You're sitting in an aircraft, you're basically in a sheet metal can. So it's a $280 billion market. So we started with automating and kind of creating a robotic sheet shaper that can do different types of parts. But the long-term goal is that we can apply this paradigm to other types of manufacturing processes. You can kind of create these kind of skilled robotic craftsmen to do additive processes, subtractive processes, assemblies. And that's, I think, it's going to create a significant impact on bringing reshoring, bring manufacturing back in the United States.
That's amazing. Let's zoom out now to the issue of research and development. Ira leads a really interesting institute called the Advanced Robotics for Manufacturing Institute, so you're really at the cutting edge of these R&D issues. Can you briefly explain to our audience what ARM Institute is and touch on what you're doing in collaborative robotics and how we can ensure smoother collaboration between humans and robots?
Sure. Thanks, Liza. So the ARM Institute is a public-private partnership. It's one of actually a network of 17 national manufacturing USA institutes, they're called, that are set up by the federal government, each focusing on a different manufacturing technology, but all of them having the same high-level mission, which is to strengthen our manufacturing competitiveness and to make our supply chains more resilient. And we do this through the assembly of a very unique and large consortium of 460 entities and counting that are leaders across academia, industry, and government in robotics and increasingly in AI. And what we do with the consortium is we develop roadmaps for all the key applications for manufacturing operations and for the DoD sustainment operations. And then we look for the gaps that are in there where we need technology as a country. We work with the consortium, we take federal funds, we close those gaps, and we make that technology available to industry as well as to the DoD sustainment community. When it comes to collaborative robots, the ARM Institute's vision is to help create a future where people and robots are working together. We do not actually believe in a sort of a dystopian factory of the future with lights out and robots just running around. That's not the future that we see 5-10 years from now. What we see are people, human beings and robots working together, where we're taking advantage of the unique skills of human beings, which are getting scarcer and scarcer in manufacturing environments, so we can't waste them on repetitive operations, using their brains, their creativity, certain processes that only they can do, and let the robots do the dirty and the difficult, the repetitive, but also processes that require a lot more precision and speed than human beings can do to stay competitive. So to create that kind of future where we have this collaboration, we need cobots or collaborative robots, and to create collaborative robots, we need AI. And so vast majority of what we do now is AI solutions to create that vision of the future. We need to make robots much better at the human-robot interaction space. We need to make robots that are much more adaptable and flexible, more autonomous to respond to new situations instead of being hard-programmed. We need them actually to be interoperable with other robots so that they can work in a factory environment efficiently, and ultimately we just need them to be better at being integrated into a manufacturing operation. So how do you get that AI solution? And the key there is data. And that was mentioned earlier today, and it's a very important point. All this machine learning and machine training for the future of robots for manufacturing depends on creating and defining data sets. One of the things that we're doing on that, because it's a big challenge, there are whole conferences on how do you get data from manufacturing, but one of the things we're doing is we have a grant from the Department of Defense in order to create what we're calling the AI Data Foundry, and that's going to be headquartered in our building in Pittsburgh, but we always use the whole consortium to create this. We are an objective public-private partnership. We are in a pre-competitive space, that everything we do with our members is pre-competitive, and so we believe we're actually going to be able to work with our members and define data sets that can be used for a variety of manufacturing applications to train robots to be smarter, and then be able to do that in an objective way, in a trusted way, and provide that back to the industry and to the Department of Defense sustainment community. So the other just final point I want to make about cobots or collaborative robots is most people think of them as basically sort of small robots because they're safer, like the size of my arm or twice the size of my arm. But we have a broader definition. Our broader definition for cobots is any robot that can work safely with a human being. So I want to give you two examples of where we're stretching this cobot space. One of them is a project that we did for the Air Force, where we have a very large, typically dangerous kind of robot you'd have behind a cage, and it's doing a very complex and toxic process that human beings really struggle to do with a big end effector at the end of this big industrial robot. And to set up the process, there's a human being who puts on a HoloLens. And the person is looking through the HoloLens and pointing, of course, in space to them, but directing the robot to some large military asset that needs this repair. And they iterate back and forth until the two of them are satisfied that they've got that repair exactly right. The robot may actually ask the person whether something it sees in its space is legitimate to go into or it should keep away. And when they're all set, the person goes behind a window, now watches the robot execute the process and can interact with them on a monitor. So it makes that really big, dangerous industrial robot actually a collaborative robot. And another final example I'll give is one that we had running in our headquarters building in Pittsburgh, which is another very large industrial robot. And what it's doing is it's swinging around a big metal box that it simulates as actually performing some kind of manufacturing process on the box. And it's swinging it around, and then it's ready for a human being to do their step that only a human being can do. So the person walks to the robot, and it immediately stops. And the reason why it stops and kind of kneels down and hands the person this big metal box to do the human step is because there's a light screen in the entire room. So the entire room is this light screen that the robot uses for vision instead of its own, optical vision on the machine, and it knows whether there's a person there safely or not. The person does their step, they walk away, the robot starts up again, swinging this thing around. So in our view, this is the kind of way that we think robotics can be used, and AI in robotics, really to meet the nation's biggest challenges and to manufacture the world's best products.
Thank you. I think, Ira, you have helped us get a picture of the optimism around the issue of industrial AI. So I want to stay on that note of optimism for a moment before I turn to the obstacles and ask maybe Ed and Chetan to weigh in. If you look out 5 to 10 years, what are you most excited about? Where do you see the most promising applications for industrial AI? Ed, maybe you want to start.
Yeah, so I think, we went through multiple generations of how AI was being used in manufacturing. And honestly, I think the definition of what AI is, what it can do, is constantly kind of is the benchmark that keeps going out there. I think it started with a lot of quality control tasks to preventative maintenance. I think now what I'm really excited about is with the advent of transformers and diffusion models, I think we can start doing more development around skilled tasks, right? Robots doing things that required very skilled knowledge before, right? Skilled, sometimes even tacit knowledge before. Think about, doing sheet shaping operation. This is something we are doing. But also a lot of other manufacturing tasks, such as welding, such as fixturing, such as assembly, and actually robot being able to do that end-to-end, figuring out how to put things together, what is the right process, the parameters, how to approach the problem, the same way a knowledge worker could do, the same way a knowledgeable human could do. I think that's the next frontier, and we'll see a lot of that in the next 4 or 5 years.
I would say sort of 3 things come to mind for me. So one definitely is a world where both humans and robots will work together. Now, they might or might not be humanoid robots. I think that we should not get fixated on that. A lot of tasks can be done by non-humanoid robots. So this world where robots and humans work together, do a particular task, and using generative AI, they're able to communicate in some sense in a natural language. So, and that sort of removes the level of interference that was needed earlier because you had to program everything. So as was shown earlier in one of the demos, we can ask a robot to do something, it will be able to understand the English language and turn into a set of tasks that it can do. So this cooperation between humans and robots, I think, would be one big thing. The other thing I would see is we'll see larger and larger systems being optimized for. So what I mean by that, if you think about a car today, so a car is a fairly complex IoT system. It has a lot of code in it. But it's being, because it's designed through one OEM, you're able to specify for all the tiers of suppliers on what specification it is, you can put it together. I think with AI now, you can have slightly more diverse systems talking to each other, and as a result, you're going to be able to optimize over larger systems. So for example, if you have a factory and you're producing something and the electricity rate goes down at a particular time, now can I schedule my manufacturing job based on the availability of power? So that's the next thing. I think you will be able to optimize larger systems. The third thing I think, which is sort of focus for us as well, is a lot of AI that we see today, for example, ChatGPT or any of such these language models, are very much designed towards cognitive workers, right? So if you want a programmer, they can help you write programs. If you're creating market copy, you can create market copy. You can write a novel or a story or a book. We believe that the real impact of AI and robotics would be when it can help the frontline worker. So by a frontline worker, I mean someone who is a technician, who's an operator, who drives your buses, or is a soldier, is a fireman, is a police officer. So if you really take a step back and think today where we are, is AI really helpful in these tasks? It's not really clear how AI is today at this point going to really impact these frontline workers. And for us, that's one thing we think about, right? How can we make AI enable and empower these frontline workers to do their job much more efficiently, safely, and contribute to their well-being? And I think that becomes increasingly important as the population decline, especially in the Western countries. So I think those three things are things that I think we'll see in the next 5 to 10 years, a decade maybe.
Thank you. So here in DC, we spend a lot of time admiring the problem. So I'm going to limit you all to a lightning round on this one. I want to hear from each of you in just a couple of words or a couple of sentences. What is the biggest obstacle you see to AI adoption in the manufacturing and industrial sectors in the United States? And Rob, I'll turn to you first, and we'll go down the line.
Companies that have a hurdle rate that is too high, they're looking for projects that are, really high returns, as opposed to a little bit more than the cost of capital. And as long as you do that, a lot of robotics projects will pay off, especially initially. That's number one. Number two, I got to say, is this massive sort of elite view that we shouldn't have automation. We saw that with the dock workers, the longshoremen. Like, China has ports that almost have nobody on them, and we're saying that we shouldn't have automation in ports. We shouldn't have automation for screenwriters. And that'd be one thing. I get unions, okay, that's what they want to do, that's fine, but we shouldn't assume that that's the right thing for the country. And the narrative now, in my view, in Washington is very much so, we can never have a person laid off by automation. And while I agree with you that cobots are cool, I don't think they're any better or any worse than real robots, or not real robots, robots that just replace a worker. NSF had a program, a National Robotics Initiative, which in theory was good, massively underfunded, but it only allowed research funding for cobots, which to me was ridiculous. We are not going to boost US manufacturing productivity unless we automate a lot of jobs. And some of it's going to be collaborative, but some of it has to just be straight up automation. And I don't think as a country we're willing to have that conversation.
Thanks, Rob. I mean, you're undermining your reputation for being able to give like a concise one-sentence answer.
I am.
Maybe we'll have you back in the future anyway. Anyway, over to Ira. A sentence or a few words. Biggest obstacle.
Yeah, thanks. I'll agree with Rob in that we need this level of automation if we're going to compete. The biggest obstacle to me is skilled workforce. I mean, we have tens of thousands of open robotics jobs right now that are not being filled, and it'll probably be, as this automation scales up, we'll need hundreds of thousands. So if we don't solve the lack of skilled workforce to support automation and robotics, who are experts and technicians in maintaining and programming robots, then we won't get to that level of automation.
Thanks. Chetan?
I would say reliability. So to explain what I mean, so most of you drive a luxury car, I would say, or some sort of a car. Luxury car has 20 to 30 motors, sometimes 40 motors inside it. And you don't realize that they are there because they always do their expected behavior. You push a button, your car seat goes back, right? AI is still not there. AI is a statistical model. So for us to see AI infiltrate or be incorporated into our day-to-day tasks in manufacturing or any other field, we need to make AI reliable. To me, that is one biggest problem we need to solve as a community, is to make AI reliable.
Ed?
Yeah. I'm going to give you a little bit of maybe non-intuitive answer is that I think the biggest challenge to adoption of AI robotics in the United States is that we don't have a robust middle section of industrial base, right? When I was at SpaceX, I'll give a quick example of what I mean by that. When I was at SpaceX, we decided to vertically integrate everything because there was not a really robust, fast, effective industrial base to support us. A lot of new companies are doing the same. Anduril is doing the same, right? Older manufacturing companies, they made themselves over years to this very thin layer of integration on top with a manufacturing industrial base underneath them. And the margin has been squeezed out of that to the point that they are not able to adopt these new technologies. So in order for us to really adopt robotics and AI, I think we need to figure out a way to reinvigorate that middle section to use these technologies, because by themselves they can't. They're just not in a good position to be able to do it.
Thanks. So in the remaining 1 to 2 minutes we have left, I hear we have an election coming up. We're going to have a new president. So if I can hear very briefly from each of you, if you had one recommendation to help solve the obstacles that you could bring to the president in a sentence or less, what would it be? Rob, I'll give you a chance.
A 5-year investment tax credit for investing in machinery, equipment, and software and AI.
Thanks. Ira.
I'm going to go back to workforce, a massive national campaign to get particularly young people into not just the field of manufacturing, but AI in manufacturing.
Chetan.
I would say Washington, D.C. needs to broaden the conversation of AI beyond the social paradigm of language models to really see how AI can be incorporated into the physical world. I think that is the most important thing.
Thank you.
Yeah.
Ed, let's close it out.
Yeah, so the US, beyond policy, the government is one of the biggest purchaser, especially in defense, of final products. So they have a really big say on what can be used to develop these products, from drones, aircrafts, missiles. And I think they should leverage that power to inject some of these new technologies that will have long-term value for the industrial base in the United States.
Thank you so much. Please join me in giving a round of applause to our panelists.